Alright, this is the first video on finding horizontal asymptotes, the Algebra 2 way. So we're going to throw it back a little bit to both Algebra 2 and Pre-Calc. So the big idea. Alright, for rational functions. To find horizontal asymptotes. Of rational functions consider the degree of the numerator and the degree of the denominator. And denominator. And then you're going to consider the leading coefficients. So there are three cases. All right. Case one, if degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote at y equals 0. Second case, if the degree of numerator, I'm going to just abbreviate, equals the degree of the denominator, take the ratio of the leading coefficients, coefficients, to find the horizontal asymptote. And then for 3, if the degree of the numerator is greater than the degree of denominator, there's no horizontal asymptote. But there is a slant asymptote. All right. So these three big ideas, or this whole big idea with 3 cases, we're going to use for the rest of the video. So first example, find the horizontal asymptote, if any, of each rational function. So for our first step, we have to look at degree of the numerator and degree of the denominator. Find the degrees of numerator and denominator. Now, okay, so I'm looking at this rational function. I see in the numerator I have negative 3x squared minus 5x plus 7x to the 4th. You can't just look in the front. You have to find the highest exponent you see. So I see the degree of the numerator is 4. All right, now let's look at the denominator. I see 5x squared plus 12x to the fourth minus 3. The degree of the denominator then is also 4. All right, so that means that now, because the degree of the numerator equals the degree of the denominator, I'm going to use case 2. So after you analyze the degrees, we're going to go ahead and figure out our asymptote. Well, the degrees are equal. All right. All right, so the degree of the numerator equals the degree of the denominator. So that means I'm going to take the ratio of the leading coefficients. So the coefficient of 7x to the fourth is 7. The coefficient of 12x to the fourth is 12. So I'm going to have a horizontal asymptote at y equals 7 over 12. Since the degree of the numerator equaled the degree of the denominator, I took the ratio of the leading coefficients. All right. Let's take a look here at B. I have negative 4x to the fifth plus 3x squared and 8x to the sixth minus 2. All right, well, the degree of the numerator is 5. The degree of the denominator is 6. All right, well, I guess we can actually write it like this. Let's write it a little easier. All right, I can just see that the degree of the numerator is less than the degree of the denominator. All right, so right here we have the degree 5 over degree 6. So this time I'm going to use case 3, the degree of the, or case 1, the degree of the numerator is less than the degree of the denominator. So we have a horizontal asymptote at y equals 0. So here we had the degrees were equal, take the leading coefficients. Here the degree of the numerator was less than the degree of the denominator, so I have y equals 0. And then over here for part C, let's take a look. Here I have the degree of the numerator is 9. All right. And that's greater than the degree of the denominator. All right. So now looking at this, I can say there's no horizontal asymptote. Looking at case 3 up here, there's no horizontal asymptote, but there is a slant asymptote. All right. But we do have a slant asymptote. All right. On the next 3 problems, I want you to pause the video and try these out. We have find the horizontal asymptote if there is one of each rational function. Go ahead and pause and try these and just test your work. All right, I'm going to keep going. All right, so I see on letter A, the degree of the numerator is 1. Because I got the x. The degree down here is 1 because I have the x. So I'm going to take the ratio of the leading coefficients. The leading coefficients are with that highest exponent. All right. So I have negative 3 over negative 2, or 3 halves. So my horizontal asymptote is y equals 3 halves. All right, let's move on to B. All right, I see the degree of the numerator is 4. You look for the highest exponent. The degree of the denominator is 5. All right, so now the degree of the denominator is way bigger than the degree of the numerator. So I have a horizontal asymptote at y equals 0. The numerator has a smaller degree than the denominator. Now, for the last one, I have degree 2. In the numerator, I have degree 3. The degree of the numerator is larger than the degree of the denominator, so I have no horizontal asymptote, but there is a slant asymptote. All right. Let's move down here to example 2. Find the horizontal and vertical asymptotes of each function. All right. Well, for horizontal asymptotes, that's what we just did in number 1 and in the U-try. So this is going to be the same as the first example. All right, so we're going to look at the degrees. Now, for vertical asymptotes, this is what you did back in section 1.5. For vertical asymptotes, we look at the denominator. All right, so let's start off with what we just did. So I'm going to first start off with the horizontal asymptote. All right. So I see the degree of the numerator is 2. The degree of the denominator is 2. All right, so now I'm just going to take the ratio of the leading coefficients, 2 over 1. So my horizontal asymptote is y equals 2 over 1 or 2. All right, now for vertical asymptotes, we're going to look at the denominator. All right, so let's factor first. I have 2x squared plus 8x over x squared plus 2x minus 8. Let's go ahead and factor out a 2x in the numerator. I'm left with x plus 4. The denominator, I have x plus 4, x minus 2. Well, I see a removable discontinuity right here, so I'm going to remove that discontinuity at negative 4. The only thing left in the denominator is x minus 2. What makes that 0 is 2, so x equals 2 is the vertical asymptote. So for step 2, we kind of we looked at the denominator. Look for the x value that makes the denominator 0. All right, so here we have 2 answers, the vertical and the horizontal. Let's take a look over here. All right, for our horizontal asymptote, I have the degree of the numerator is less than the degree of the denominator, so our horizontal asymptote is 0. For our vertical, let's go ahead and factor the denominator. So I see it's x to the 4th and x squared, so I'm going to put x squared. The factors of 20 that add up to negative 9 are negative 5, negative 4. I'm trying to find when these are equal to 0, so I just set each one of these equal to 0. Add 4, take the square root, x is plus or minus 2, add 5, take the square root, x is plus or minus the square root of 5. So we have 4 vertical asymptotes here. So here's our 2 answers. All right. Now let's go ahead for the last one over here. I see the degree of the numerator is greater than the degree of the denominator, so there's no horizontal asymptote. Because we have degree 3 and degree 1. That's a difference of cubes, but I know I'm going to get x minus 8, and that's not going to cancel with the x plus 11. So our vertical asymptote is x equals negative 11. All right. For this, go ahead and pause the video. You're going to try these 3. Find the horizontal and vertical asymptotes, if any, of each rational function. All right. So here for our horizontal, I have the degree of the numerator is greater than the degree of the denominator, so there's none. For our vertical, we're going to factor first. Up here I have x squared minus 4, x squared minus 9, all over x plus 3, x plus 3. Let's keep going. I have x plus 2, x minus 2, x plus 3, x minus 3, over x plus 3, x plus 3. Let's cancel one of the x plus 3's. The only x value that makes our denominator 0 is negative 3. So here's our vertical, here's our horizontal. All right, take a look over here. For horizontal, I see the degree of the numerator is 2, the degree of the denominator is 2. So if I take the ratio of the leading coefficients, I get 1 over 1 or 1. All right, for the vertical asymptotes, let's factor. I have x squared over x plus 4, x minus 4. I can't remove either one of those discontinuities. So my vertical asymptotes are x equals negative 4 or x equals 4. All right, for the last one, the degree of the numerator is 0. The degree of the denominator is 4. So we have the degree of the numerator is less than the degree of the denominator, our horizontal asymptote is y equals 0. All right, for vertical, we got a factor. I have 11 over, that's x squared minus 4, x squared plus 4. I can't factor x squared plus 4 over the real number, so I'm going to leave it. And let's go ahead and factor the next one. So I have x plus 2, x minus 2, x squared plus 4. So my vertical asymptotes are x equals negative 2 and 2. All right. Last example, slant asymptotes. Find the slant asymptote if there is one of each rational function. All right. So a slant asymptote occurs when the degree of the numerator is greater than the degree of the denominator. So I have degree 3 over to degree 2. So the first step here is if you want to find it, you're going to divide. So x cubed minus 1 divided by x minus 2. Now, when you divide polynomials, you need placeholders. You got to have a place value for each of the terms with an exponent. So I'm going to go ahead and write in my place values right now. X cubed plus 0x squared plus 0x minus 1. I have x minus 2. X goes into x cubed, or what times x gives you x cubed? That's x squared. You multiply it through x cubed minus 2x squared. Put parentheses around it and subtract. X cubed minus x cubed gives you 0. 0 minus negative 2x squared is a positive 2x squared. Now I ask, x times what is 2x squared? Well, that's plus 2x. Multiply it through 2x times x is 2x squared minus 4x. Bring down the 0x. Let's go ahead and put parentheses around it and subtract. 2x squared minus 2x squared, 0. 0 minus negative 4x squared is 4. Or minus negative 4x is 4x. Now, x goes into 4x how many times? 4. 4 times x is 4x. 4 times negative 2 is negative 8. Bring down the minus 1. Let's subtract. 4x's cancel out, and I'm left with a remainder of 9 because x can't go into 9. So I'm going to do plus 9 over x minus 2. Now, for slant asymptotes, what you're going to do is you take the result of division without the remainder. So I'm going to take the division, the result without the remainder. So I ignore the remainder. That's the 9 over the x minus 2. This right here is my slant asymptote. All right. Go ahead and box my final solution. Let's run through one more. So again, I'm just going to go ahead and divide these polynomials. So x minus 1, x goes into x squared x times, multiply it through, and subtract. 15 minus negative x is 16x. X times what is 16x? 16. Multiply it through. Go ahead and subtract. Negative 2 minus negative 16 is 14. X can't go into 14, so I have plus 14 over x minus 1. You take the result that doesn't include the remainder. That's this right here. So y equals x plus 16 is our slant asymptote. Here's one you try. I want you to find the slant asymptote. All right, so go ahead and pause the video and you're going to try this one out. All right, I'm going to get started. I have 2x squared plus 5x minus 1. All right, x times what is 2x squared? That's 2x. Multiply it through. I got 2x squared plus 6x. Subtract. These cancel out. 5x minus positive 6x is negative x minus 1. X goes into negative x, negative 1 times. Negative 1 times x is negative x. Negative 1 times 3 is negative 3. Parentheses and subtract. Negative x minus negative x cancels. Negative 1 minus negative 3 is 2. All right, take the result without the remainder. Y equals 2x minus 1 is your slant asymptote. This concludes video number 1 for notes for tonight.